describe yourself as a network extension platform. So what exactly does network extension mean?
The way I view it, network extension is an umbrella term. So it includes various different types of scaling solutions.
Anything specifically about systems engineering philosophy that, the Solana community has that spoke to you?
So I will say the learning curve for writing anchor contracts and working on Solana is a bit steeper than Ethereum and Solidity.
This is a fairly deeply technical problem. I guess there are like 5 companies who do this. There's a standard path for an engineer to get hired at DeFi. They're reading through contracts. How do you hire?
For our hiring process, we
There is also the Solana permissioned environment, right? Is it fair to say that SVM engine can be an instantiation of the permission environment for use cases?
I would say SPEs are maybe orthogonal to SVM engine because
Hello everyone, welcome to another episode of the One Day Dev Pod. Today we have with us Yiwen from Termina. Hi Yiwen, welcome to the podcast.
thanks for having me.
I remember from our previous conversation that last time we spoke, I think you had already made the jump. You come from a traditional CS background, and then you were considering making the jump, or you had already made the jump to crypto. So I'm curious to hear more about your journey from coming from traditional CS and jumping into crypto. And also, it's been 2 years since we last spoke, so would love to hear more about your journey.
Yeah, absolutely. I think when we last spoke, I had already switched over full time to crypto, and that was when we were first starting out Nitro. So it was actually right after FTX happened. So it was a very interesting time, very different time compared to now. Before that, I was working on crypto, but just in my part time, separate from my full time job. So kind of moonlighting as a crypto builder, nights and weekends. I guess just to give a bit of background about myself, I have a pretty traditional software path. So I studied computer science for my undergrad. And then I moved out here to the Bay Area after graduation to work as a engineer at Lyft. I was working on data and infrastructure, so a lot of Kubernetes, a lot of big data processing, that type of work. And before Lyft, I also previously interned at Microsoft and SpaceX too. So a lot of very more low-level infra type of work. I think one thing that I was missing from my Web2 work was one, everything is proprietary. We had a very strict policy against open source, so I knew that there was a cap or a limit to the impact of my work. Like only engineers at the company would benefit from it, but not really anyone beyond that. And then the second thing is I've always been interested in distributed systems, and I tell everyone that it was actually one of my favorite classes in undergrad. But I didn't get to work too closely with it. Granted, Kubernetes is distributed, but it's not to the same extent that blockchain systems are. So those were my 2 main reasons to start looking into building on blockchain rails. And from there, just found myself doing it more and more and decided that it was worth it to make the jump and quit my full-time job and make this my full-time.
You chose a very weird time to join crypto full time. Are you saying you joined crypto right? Oh, okay. Yeah.
I was working in crypto before, but my initial projects were in the Ethereum ecosystem. When we started Nitro, it was after FTX. So I think it was that time when I made the decision to 100% commit to Solana, a lot of folks around me were telling me, no, Solana's gonna die. Like, FTX is like draining the whole ecosystem. Everyone's leaving. You should just continue building on Ethereum. But I think we saw from a first principles perspective that there was still so much activity and innovation that was happening on Solana. So despite the SOL price being single digits at the time, it wasn't an accurate reflection of the work that people were actually doing in the ecosystem.
Anything specifically about engineering or the systems engineering philosophy that the Solana community has that spoke to you? I'm sure it's just not the price, right? But also fundamentally all the work that is happening, that was happening at that time around, uh, SVM and also the local fee markets. There was so much work that was happening around priority fees as well.
One of my past projects, we were building an ad network on Ethereum, and uh, a lot of the smart contract work that we had to do was frustrating for me, because I had to think very closely about gas fees and reentrancy and different attack vectors and just trying to keep as little on chain as possible because things were so expensive. And then that was what sort of pushed me to start exploring alternative ecosystems like Solana and also Cosmos. And especially for Solana, a lot of the features that uh, people maybe not take for granted, but that are just available off the shelf are there ready to use. So check, as you mentioned, there's local fee market, so you don't have to worry about one NFT mint spiking up gas fees for everyone else on the chain. There's also parallel processing, which makes things a lot more efficient. There's other programs that are built in, not like enshrined in the protocol, but just as SPL. So like account compression, concurrent Merkle trees, all of those things are available, ready for you to use, ready for you to build with. So I will say the learning curve for writing anchor contracts and working on Solana is a bit steeper than Ethereum and Solidity, but after you get over that initial bump, you're allowed to do, or you're able to do so much more on chain than in Ethereum.
Makes sense. You mentioned you worked on an ad network on Ethereum, and you guys mentioned Nitro. For myself and for the audience, do you mind sharing some context on what Nitro was?
So that wasn't Nitro. That was a previous project. That was a different project on Ethereum. That was yeah.
Makes sense. But was it a blockchain project or was it a Web2 project?
It was a blockchain project. Yeah. But that wasn't Nitro. But I can give you an listeners a better idea of what Nitro is doing. So Nitro Labs is the main our company, and the main platform we're building is called Termina. And our goal has always been to scale Solana. So helping teams scale on Solana without necessarily creating a separate network like an app chain or a rollup. Different teams run into different resource bottlenecks on Solana. Sometimes that's data, sometimes that's latency, sometimes that's throughputs. And so we want to help teams get past these bottlenecks and be able to build on Solana without having to move their data or their workloads off chain. So that's our main North Star goal. And as part of our Termina platform, we have different a toolkit that you can use of different extensions to be able to get past these resource bottlenecks. So one that we've been working with different DePIN teams on is data anchor. This allows you to put a massive amount of append-only data on chain, which lends itself very nicely to proofs that DePIN nodes have, like proof of bandwidth, proof of uptime, proof of contributions. And then some of our other work has been in the ZK-SVM, which Shek and I were talking about earlier, and also the SVM engine, which is like a dedicated SVM environment. But I'm sure we'll get into all of that. Sure.
It's fascinating you mentioned, helping scales Solana. As the blockchain, it's like a very contentious environment for running computation. It's not just computation. You have both, one, it's actual computer and also the memory. So looking at your suite of product, it looks like, you have one specific module to scale data storage and one specific module to scale compute. Is that like a very deliberate thought process? So does that mean that you're also doing something to scale network as well?
Yeah, so everything we built is on top of the L1. We're not contributing to the L1 directly, so we're not working with consensus or networking or at that layer, but it's an additional layer on top that broadens the horizons for what people can do on chain. And typically folks will ask, well, Solana is the highest throughput chain or one of the highest throughput chains compared to all the other blockchains out there. Why are you guys trying to scale Solana when it's already supposed to be such high throughput or such low latency? And Solana is more performant than some of these older L1s, like EVM based L1s, but it still has a ceiling. So the ceiling is much higher than that for Ethereum, but the ceiling is still there. And as more and more workloads and projects are coming on chain, that's going to stress the network even more. So we need a scaling is not a solved problem, obviously. Like that's why Anza's working on 𝗼𝗺. There's a bunch of different efforts, and I don't think it'll ever be a solved problem because even in Web2, um, when it's a centralized system, people are stressing the data centers all the time, and we still need to expand the amount of data storage that we have, the amount of latency and throughput. So even in a centralized environment, it's not a solved problem. And so in a decentralized environment like a blockchain, it's still going to be a constant problem that you just work continuously over time to be better and better.
The base layer for all of this is the network. So once you have a larger pipe, that means that you can pipe in a lot more things, lot more computation requests or a lot more data. It's just that you necessarily don't have to do them on the L1 itself. So you kind of extend the network. So you have a separate way to scale compute, and then you also have a separate way to, scale storage. Is that a fair way to think about network extensions? People often talk about network extensions in the context of Solana, right? And Termina, in your you describe yourself as a network extension platform. So what exactly does network extension mean?
Yeah, good question. So uh, the way I view it, network extension is an umbrella term. So it includes various different types of scaling solutions. It uh, is a superset of rollups. So it includes rollups, but it's not synonymous with rollups. It also includes these newer things which we're doing, which other teams are doing, like Magic Block with their ephemeral rollup. Maybe ZK compression you can consider under this network extension umbrella too. So that's how I would differentiate network extension from rollup, even though those two are conflated by folks sometimes.
One of your module is also the SVM engine, right? So is what exactly does it do? Is it the same as your ZK-SVM, or SVM engine and ZK-SVM are different? Or maybe you could talk us through the different things so that it's easier for people to understand.
Yeah, for sure. So just giving some background context, we started out building a rollup stack on Solana, and we are still serving some users with this rollup stack. However, we don't want to prescribe a rollup architecture for every team that wants to scale on Solana. It's a rollup makes sense for certain use cases, certain situations, but it uh, more often than not doesn't make sense for teams who want to benefit from the composability of Solana L1. So when we had so given this rollup stack, we were working with different users who wanted to scale on Solana. They would just point at a specific piece of the stack. Like we like the data availability layer. We want to be able to put more data on chain, or we just like the execution and having low latency, but we don't want the whole full stack. It's too heavy of machinery for us. And so that's what prompted our transition into more lightweight network extensions, where it's not all or nothing. You have to use entire rollup stack, but the rollup stack consists of different scaling elements within it that can actually be broken down and used in a modular fashion. So that's sort of the context for our move into network extensions. And then currently we have three main modules. So one is the data anchor, which we've already touched on, and then the other two are the SVM engine and the ZK-SVM. So the ZK-SVM is sort of similar to the SVM engine, but it's different in that you can generate a ZK proof over any arbitrary SVM computation. You can send that proof on chain, have that proof be verified, and then that triggers additional actions on chain, as if the original computation happened on chain, when in fact it did not. So that way your off-chain computation can be more closely tied to what's happening on chain. And the way we've structured it is as a Groth16 proof based on Succinct's SP1. And so for Groth16 style ZK proofs, it's the verification cost is constant. So no matter how expensive or how complex the original computation was, when you verify it on chain, the proof is always 260 bytes. So it's always the same cost.
Interesting. So, as I understand it, SVM is like you can take the SVM API, or you can take anything, any compiled Solana program, and you can run it anywhere. And then that, so does the SVM engine only worry about executing these computations, or does it also worry about the state?
Yeah, that's a good question. So the SVM crate that's part of Agave by itself is just a pure SVM environment. So you have to set up the initial genesis state, and then you can configure the block time, the feature flags. Like there's a bunch of things that you can customize yourself. So that comes out of the box from Agave. What we've built on top of the SVM engine is the connection with Solana L1, because an SVM environment by itself is not that valuable. It's useful in its connection to the L1. And so we have a syncer and relayer process that pulls state from the L1, populates it into the SVM engine, and then you can interact with the SVM engine. You will get very instantaneous results, like less than 50 milliseconds for the block time. And then we take care of sending this on chain on your behalf.
Does it mean state between the mainnet and the SVM can just move around, or is it more like you kind of bash this transaction and hash them together into a Merkle root and then post them into the mainnet? Like,
The former. So we forward transactions from SVM engine to the L1. So the transactions are actually propagated and rerun on the L1. It's not only the state that's submitted.
what type of use cases need it? Where is it use cases where I'm guessing this might be use cases where you need faster confirmation that you can execute, and then you also get the proof that this is what actually happened via re-execution on the L1. So it's kind of like the trade-off here is the latency versus the actual computational cost.
Exactly how I would say it, which is the category of projects that are benefiting from SVM engine would be in DeFi mostly, where they care a lot about latency, and they sometimes also want delayed visibility or a later scheduling of that transaction on the L1 and have it be visible to everyone else. So they will get near instant confirmation of what the resulting state would be like from that SVM engine, and then they'll set future time. For some teams it varies. Like for some folks they want it on the L1 as soon as possible. For other folks they want it in 4 hours or in 24 hours on the L1. And you can think of it as being like a very fast and fancy simulation engine in that sense.
There is also the Solana permissioned environment, right? Is it fair to say that SVM engine could also be can be an instantiation of the permission environment for use cases where you need a custom validator set plus custom block time, but then you also want to kind of rerun these transactions on the mainnet. The main trade-off is that you're, actually you get lower latency than what you get on mainnet, but then that but then that's okay because you also have this computational proof on the mainnet.
I would say SPEs are maybe orthogonal to SVM engine, because my understanding of an SPE is that it's a completely separate L1. So there's no connection to Solana at all. And SPEs are typically used in enterprise environments or environments where there's maybe regulatory concern, and they need it to be KYC'd or KYB'd. So I know some companies are using SPEs, and then there's also Sphere. They have their own SPE environment so that banks can send money to each other on the Sphere, on SphereNet. I think that's what it's called, rather than on Solana L1. So As far as I know, there's no connection between SphereNet and Solana L1, but they're running the same agave code. So SphereNet is a Solana permission environment that's separate from Solana L1.
It's an interesting mix, right? You have the SVM engine and the ZK-SVM. It looks like both offer very similar functionality, where the trade-off that you're making is for latency, and then the computational proof you get via re-execution on the mainnet. With ZK, it looks like you're able to generate the proof yourself. So, what was the thought process behind? Was it the specific customer driving that, or how did you arrive at like an SVM and the ZK-SVM?
Yeah, the initial set of users that we built the ZK-SVM for was actually SVM rollups. So I'm sure you guys know, besides our team that was building the rollup stack, there's also Sonic with their gaming focus, but I guess they're more general purpose now, SVM rollup. But there's also Soon, there's Eclipse, Magic Block too with their ephemeral rollup. So the ZK-SVM is a way for SVM rollups, and beyond SVM rollups, just like off-chain SVM computation, to be able to prove that they did the computation correctly. So when you have the ZK-SVM, you can just have a single validator or sequencer run the computation. You don't need a fully decentralized network. They just need to generate a proof, submit that proof on chain, and the chain can check that the computation was done correctly from the proof. So it's a different way in a trustless environment, where you don't trust someone. You don't need to necessarily re-execute their entire computation. You just take a proof that they give you and check the proof.
Got it. So how do you go about generating these proofs? Like, Solana programs are typically either in Anchor or Rust. So is it a gadget that people add on top of the existing programs, or do you have like or you have like you operate at the bytecode level?
Yeah, so we initially thought it would be a very simple problem, but it turned out to be a lot more involved, because even though people write Anchor contracts in Rust, they do not deploy the raw Rust on chain. They compile it to bytecode and then they deploy the bytecode on chain. So if you're the maintainer of a rollup or your own custom SVM environment, you don't get access to people's raw Rust code. You can only get access to their bytecode. And so what we actually do is we run Solana's eBPF or RBPF interpreter inside the ZKVM, and then the operations of the interpreter is what we prove over. So instead of proving the contracts directly, we actually prove the interpreter, which runs the contract. So there's 1 degree of separation there.
So when you talk about like off-chain computation, it's like it's the proof is over the entire computation. It's like, what if in a program I have like one specific one specific computation which is long running or expensive. For example, in Web2 you would probably put them in a background job, right? Some imagine such a scenario. Would ZK-SVM work there, or is the intention, are you doing something so that it is applicable for such use cases, or they're not even the consideration set for you, and you are looking at it purely from the perspective where take existing programs and then execute it off chain so that you get like unbounded compute?
Yeah, so one of the constraints of the ZKVM, so not only Systink's ZKVM, but I believe RISC-0's ZKVM as well, is that they're single-threaded, and so you can run only one transaction at a time. Solana allows for parallel processing. I think there's 4 threads that process non-vote transactions at the same time, and so you do have those transactions that happen at the same time, but because they're scheduled to be parallel, that means they touch independent state. So it doesn't really matter what order you execute them in. You can do 1, 2, 3, or you can do 321 or 213. It doesn't really matter because they touch different state. That's why they're scheduled to be parallel. And so in the ZKVM, it's not going to be as performant as Solana because there's only one thread, but it's still going to be correct because we can just unroll the parallel transactions in any order, and we should still be able to get the same state that the original computation created.
Interesting. One thing that really caught my attention is that in your talk at Scalar Die was, how you were wrangling. So SP1 was, you generate proofs using SP1, and SP1 and SVM are like two completely different systems, right? So it looks like there was a lot of really hardcore, integration work that you guys had to do to get it to work. I would love for you to talk more about it, like all the problems you encountered there.
Yeah. So besides the one I mentioned of us needing to run the BPF interpreter rather than the raw contract code, the BPF interpreter also assumes that it's running in a 64-bit machine, which is a fair assumption to make because most hosts are 64 bits nowadays. But the ZKVM is only 32 bits. So initially, when we tried to run the interpreter inside the ZKVM, we ran into so many invalid memory access issues because the pointer math was off, 32 bits versus 64 bits. And so we actually had to make a few set of changes to Agave so that it can run in a 32-bit environment. And so that involved adding, I guess you can call it backwards compatibility for 32-bit pointers. And so we made that in our fork of Agave, and then we contributed most of those changes back upstream so that everyone can benefit from this and they can run Agave in a ZKVM or in another 32-bit environment. But I think most of the usage would be for ZK.
Why are ZKVMs like only 32? Why are they 32 where, rest of the, where 64 is the standard? Is there any specific reason why that's the case with ZKVMs?
Yeah, that's a good question. So Succinct is actually, and I believe RISC-0 too, both of them are working on adding 64 bits. It's just 64 bits. There is a wider set of instructions, so it's just harder, more difficult, more work to support. So I think that's the main reason why they have 32-bit first, and then they're working on supporting 64-bit right now.
Sense. Switching gears a bit, I'd love to know how do you hire? This is a fairly deeply technical problem and not something, I guess there are like 5 companies who do this compared to probably 20 who do DeFi. So there's a standard path for an engineer to get hired at DeFi. They're reading through contracts and, I guess reverse engineering ideas and figuring out what's up. But how does one get hired at a company like yours who's building an L2 or rollup? What kind of education, curriculum, projects should they go through?
Yeah, typically for our hiring process, we don't ask that people have direct experience with the stacks that we work in because everything we're doing is so new. Like Solana has only been in existence for 4 years, and we're also working with some frameworks like Sovereign SDK, which has only been in existence for like a year to 2 years. And so if we limit our talent search to people who've worked with those very specific technologies, then maybe there's only 12 people who are eligible by that criteria. So what we value more is that someone can learn really quickly and they can unblock themselves quickly. So more so than experience, we value just speed of learning and ability to pick up new things.
Got it. And how do you interview for that? How do you know if someone fits that criteria well?
So as part of our interview process, we have a series of technical challenges, and then folks are allowed to write code in any language they prefer. So actually, one of our engineers didn't have any Rust experience prior to joining our team. So he did all his challenges in C. You can pick any language you want. We're not prescriptive there. And then the challenges are general problem solving programming challenges. So as long as you can think on your feet and you're pragmatic about solving a problem, you should be able to do well on those challenges.
Sorry, when you say one last question, when you say problem solving, do you mean lead code like problem solving or something more specific?
Yeah, you can consider them leak code problems, although I would say they don't rely on some like trick that you have to get. Whereas some leak code problems, it's like um, there's only one way to solve the problem, and you have to know the trick in order to solve it correctly. For us, it's more I would say it's more general purpose. There's different ways you can solve it, and it's tied more into actual problems that we see in our day-to-day work. So it's not just abstract like dynamic programming problems that you probably won't ever get to use or implement in real work, but it's actually very closely tied to stuff that we do in our day-to-day.
Awesome. Are there any roles that you're hiring for?
Yeah, so we are always open to engineering talent. And right now we don't have much of a front end or full stack um, opening. It's more back end work that we're doing. So anyone who is confident in their back end skills would like to join a fast paced startup, build Solana infrastructure, and help scale Solana, definitely feel free to reach out to me.
Got it. And also, I'm curious, what does the culture look like once someone joins? So do you guys follow like some sort of a scrum? Are engineers mostly solving research problems and trying to understand the tech that's, as you said, is evolving really quickly? Or is it more streamlined, simpler? Are you spending your time coding or are you spending a lot of your time researching?
During the first year of the company, I was writing a lot of code. You can look at my GitHub commit history. I was like pushing commits every day. Now that we have more of a fuller team, I'm spending more of my time on the product side. So thinking about product strategy and working with users and blocking them. And I'll still review PRs and I'll write some code every now and then. And then we have a few UIs that we've built for our users, and I actually do the front end work on those because everyone on the team hates front end. And so I'm just doing that. But it's that's not the majority of our work. Like the majority of our work is back end, on-chain and off-chain infrastructure.
Yes, one last question I had on data anchor, which we couldn't get to. So when you say projects, folks are using, especially deepened projects are using this to write data to, what type of data are they writing? It's like, so when you look at the spectrum of, data solutions that are available, you have Filecoin, RV, Go, and much more recently TapeDrive. So is it something like that? Or is it much more like their concern is more about data availability? So I'm curious to understand what use case it what use case it is for.
Yeah, absolutely. So for any deepen project, as the name suggests, it's a decentralized network of nodes. So you have uh, individuals or maybe small organizations that are running these nodes and contributing to the network. And because it's an open, permissionless, and trustless network, you have to make sure, as the protocol operator, you're incentivizing and rewarding the right people. So you want to make sure for good actors, you're giving them rewards for their contributions, and for bad actors, you are disincentivizing them and not giving them rewards for faking their work. The only way that you can that someone is doing the right thing is if they give you a proof of their work. And for different deepen projects, it looks different. Like for like a decentralized ISP or decentralized internet access, you may have a proof of bandwidth. For decentralized storage projects, you may have a proof of spacetime, that the node is actually saving or having the data that it says it has. And then for the bandwidth case, you want the node to show you that it actually has the internet capacity it says it has, and it's actually transmitting user data. So for different deepen projects, there's different types of proofs, but you a proof is a non-negotiable aspect of the protocol, because otherwise you don't know. It's not your own people. It's not your own company that's running the nodes. It's a network of strangers that you don't really know. And so this proof data you can send on chain, and there's different solutions even on Solana for storing data on chain, like with state compression, ZK compression. It's a Merkle tree. It's a concurrent Merkle tree, but that doesn't lend itself well to append only data, because you have to decide the size of the Merkle tree up front. And for an NFT collection, there's going to be like 2,000 NFTs in this mint. It's never going to grow. But for proofs, it's you don't have a cap because it's append only data. So you need a different type of data structure in order to anchor this on chain. And so that's where we come in with data anchor, where it's optimized for data blobs that are continuously coming in, and you just need to accumulate more and more proofs over time. So that's how we're working into putting with some of our deepen users.
Interesting. So it's more of a proof store versus a traditional decentralized
Yes.
data store. Okay, got it. Yeah, that makes sense. So technically, if someone were to even build a different rollup, they could still use your data anchor to kind of like post these blobs. Do you also provide DA over the data that is anchored?
Yeah, we provide an indexer. So everything that goes to the data anchor is stored on Solana. So it's stored in the ledger history, and then a commitment is made in the account space. So anyone can hit an RPC node if they sent the data within the past 3 days, and then if it's beyond that window, they can hit an archival node. So everything is, you can use it without us, but we provide an indexing service where we will pull this data, format it into a relational database structure with different tables and timestamps. So it makes it much easier for you to query, like from this window, July 4th to July 10th, what were the data blobs that came in? Who sent those data blobs? It's much more of an ergonomic interface than you having to remember the transaction signatures and the slot number when you send a request to an RPC.
We are towards the end of the podcast. Thank you so much for joining, Yiwen. It was such a pleasure to catch up with you and also to have you on the podcast.
Yeah.
So thank you so much for joining us.
Yeah, thank you for having me.
Thank you.
Okay. All right.